science of milk, and we've got milk everywhere. Easy to be able to do. Need some food coloring and some soap, and it's a fairly amazing thing. Let me show you what it looks like first, then we'll do the science. Fair enough?
All right.
This is just whole milk. All right, so I've got a plate of whole milk sitting right down here in the very middle, which you can see. And now I'm going to take some food coloring and just put a couple drops of food coloring in. You'll see why here in just a second. Okay. And now, Mark, over there in the blue bottle is the secret, and that is...
Oh, our favorite Dawn dish detergent.
Nice, Dawn dish soap. Now,
very important science product. If
instead
you're a
of pouring it in, here's what's going to happen is I've got a little bit on a Q-tip.
Oh, I see.
All right, so here's a little cotton swab. So hang on to that.
We just need a little bit.
So what I want you to do is pull some off, and like this, and kind of just twist it up a little bit so it's not going to drip in like this. Okay. And then I want you to touch it in the very middle while we're looking right there. Touch it in the very middle and stay right there. Go and touch it. Nice job. Keep going. Set it in there. Nice job. Just let it go.
Go for it.
Isn't it nice? You can just actually just lay it down in there if you want to. Is that kind of nice? It's just this beautiful burst of color.
Wow.
Isn't that just amazing? It's just going to continue to burst and move and so forth. And it's actually some really, really cool sciences. I show you the other ones here of milk and, believe it or not, of soap. And so it's the science of soap. Soap is amazing because it has, if you were to look at the molecule of soap, it has this long tail on the end that is kind of like fat. First soaps were made with lye and wood ash or fat.
I remember I was out there cooking and stirring. You know.
So the way milk works is there's fat in that milk, and so soap, when you put the soap in there, it's moving around trying to collect all the fat globules, and that's why you see the movement. So here, watch this over here. We've set up a little science experiment. This is 1% milk, and this is half and half.
Milks have a different effect.
A different amount of fat. So if we start over here on the end, take a look at this one here on the end. When we touch in the middle here, look at this. You get that beautiful movement. Isn't that gorgeous?
That's
so there's
1%. 1%.
And so 1%,
very cool.
and you're kind of sitting here going, well, what about 2%? So we move over to the next one here. This is what 2% looks like, right sitting here in the very middle here. Watch this. This is 2%.
Ooh, also very cool. Ooh, that's very cool.
So now you're sitting there going, wow, that really is taking off. Look at it. It's just moving, and it doesn't stop. It just kind of keeps going and going and going. So that's really, really pretty. If you take a look at this. Take a look at that second dish right there. It just continues to go and go and go.
Yeah.
I feel like the director because I'm calling shots. This is kind of cool to take a look at.
Bobby Pusatore, very accommodating.
Would you look at this? I have two of these. This one's very, very cool because this is, if you take a look at it, this is buttermilk over here. All right?
Buttermilk even better?
Buttermilk. I've got this one here. I'm just going to put and drip it in the very middle. So here, watch this. This is buttermilk. Buttermilk doesn't move much at all, but watch this. As soon as it hits, it's going to start. Oh, look at this. See how it looks like it's crystallizing?
Oh, look at
Tell me that's not the coolest thing. Honestly, I've been doing this experiment for 20 years. I've never seen that before. So that's a first as we were kind of playing with it.
Did they change buttermilk or something?
No, I've just never tried it with buttermilk. So that's the problem. And look at over there. Here's half and half. So if you look at this very, very last one sitting over here, this is half and half, and this is just the drop in the very center. And again, of course, it's going to be beautiful.
This is almost like a piece of art. Look at that.
And speaking of the art, this is how we wrap up there. I've got a tray for you in the very middle, but guess that's not milk. Look over there. What is it, Mark?
Elmer's glue.
Why not? It's white. No,
have you ever tried it with Elmer's glue before?
Yes. Synthetically, this is very, very cool because Elmer's glue, of course, does not necessarily have a fat in it, but it has a polar side of the molecule and a non-polar side of the molecule. And when you put a little bit of soap in here like this, you get the same kind of movement, but it's just gorgeous. But now watch. So you see the bursting that's happening here in the very middle?
Test or something.
So watch. Let's say that's done and you let it dry. Now watch this. Hang on to that. I'll take this one right over here. Watch what happens. Peel it off. Watch this. Peel it off.
Can I peel this one off?
Yeah, absolutely. Take it off. And so now you've got this wonderful, is that nice?
That
little
is
stained glass
a young scientist would love this. So this is the Elmer's glue that you can just let it dry.
Absolutely.
Oh, look at that one.
Isn't that kind of fun?
That's right.
So I think it's kind of nice for the summertime, simple to be able to do. There's nothing better than that buttermilk. Look at that one. That second from the end is...
It does. It looks like, now it's like a
I've just never seen the patterns before that kind of come out here in this one here. It's just absolutely fascinating.
I have to tell you, that's a remarkable thing. You bet.